So we were saying that why the ROI is a good index, because if you calculate the ROI, okay, and you obtain that A is very high, this will be good or bad? Who will tell me?
It's going to be bad.
No, it's going to be good. You know why?
The
Because
A is being smaller than ROI.
yes, exactly. But in
As
this
a
case,
high,
you will have a higher range of, and even if you're not confident in future, you can have a possibility of having this project economically viable. So let's say if you obtain a return on investment 10%, this means that 10% is already high, so you are not confident in future. So if I take then a country that is not very risky, intermediate country, a 5%, then I will have a profitable project. Okay, so higher is the ROI, the better is, because this will increase the intervals of A for which my project can be profitable. Okay, while if you obtain a very small A, this means that the range of application, the range of confidence that you have is very restricted. So let's say A is 2%. This means that only very safe countries and countries where you have a very high confidence in the future, you can do in them this project. Okay, this is why higher is the ROI, but the better is. Okay, so in the question here, we want to calculate the rate of return on investment for which correspond to the discount rate for which the NPV becomes zero at the end of lifetime of the system, of the turbine here. Okay, so which formula we will use in this case? Who will tell me which formula to use? We will use the net present value at the final year, okay? And when we consider the net present value at the final year, we should not forget to add what? The salvage value, okay? Because only at the final year I will add this term. So the net present value, which constitute a balance between income and costs for the whole lifetime of the system. It will include, of course, the initial investment, and it's minus I because it's a cost. It is plus the salvage value because it's an income. And over each year, for each year, I should calculate the balance. So this is the balance. This is the balance over the years. Okay. So this is the balance over years of incomes and costs. Okay, incomes and costs. Okay, so what we will do, we will write the expression of NPV, function of the variables that we have in this problem, and try to find what is the value of A that will give us 0 for NPV. Okay, so let us write it together. What is NPV in our problem? NPV, so NPV for year N is equal to, first we have which is N here is equal to 20. Okay, NPV for year.
Miss, why are we taking it at year 20? No, we are to get the A, we are interested on the entire يعني لازم تكون minus
ما هو
I plus
هو الانتاير lifetime هو 20. ما هن قالوا لك انه this turbine can work 20 years. يعني it cannot work more. This is the maximum lifetime of it.
Yes, but you said we need يعني هون ما خلص I got maybe أنا فهمت شيء غلط، ما في مشكلة.
ما أنت by definition شو هو ال ROI؟ ال ROI is by definition the discount rate اللي correspond NPV 0 at what time? At the end of lifetime. يعني at 20 years. Okay?
Yes, but we are going to include هلا in our equation. We should include in our equation for each year كمان ال RI minus CI ما هيك؟
أكيد. ما it's a summation
it's
from
going
one.
to be 20 term يعني.
Yes, exactly. Yeah. But you have a formula that from math you have a formula for geometrical series that will help you in reducing the number of terms. and we'll see it together.
Miss, عندنا كمان Excel. Can we use Excel?
You can use Excel. You can use what you want. If you
we
develop,
can use Excel in the final and with Excel بتاخد معنا ماشي.
you can use what you want. Okay.
Okay.
يعني what I care for is that you understand the method. If you understand the method, you will be able to develop an Excel sheet that you can use in your problems. Yes, no problem. Okay, but I need to see all the calculation details on your draft. Yani even if you use the Excel sheet, I need to see the details. Yani we will see together what are the details. Okay, and you should show them in your exam. Okay.
Yes. Okay. بس الcalculation بيكون Excel.
Yes, you can do calculation on Excel, no problem. Okay, so first we have that, as we said. Okay, so NPV is equal to 20. At the year 20 is equal for the initial investment. Okay, so let me write it here as a tax better, so then I will give you the tax after we finish. Okay, so NPV, let me clear everything. So NPV at year 20 is equal to the minus the initial cost, so minus 6,000. Here you should pay attention. This term in general, this term here, if the income and costs are constant over all the years, then no need to divide it into parts. I just can compute the summation. But here I am forced to divide it into parts. Why? Because if you go to the given, if we go back to the given, the income is different over years. So for year 1, what was the income? 0.13 euros per kilowatt hour. So how you find the total income per year for the first year? What should you do? You should multiply by the number of operation, by the number of kilowatt hour per year generated, which are 7,500. And this will be R1, yani the income for year 1. And the income for year 2, you multiply by 0.12. The income for year 3, you multiply by 0.11. But after year 4, it becomes constant. So let us see how to deal with it mathematically. So here, since whenever I have a different R, I should decompose my term here. So first I will take for the first year, for year 1. For year 1, what is the case? It's R1, which is the income at year 1, minus the cost at year 1, over 1 plus 8. Okay, so this is for year 1. Now plus for year 2, what do I have? I have the same formula, but instead of 1 plus 8 to the power 1, it becomes what? 1 plus 8 to the power 2. Because for each year, I should divide again by 1 plus 8. This is why it will accumulate over year. So for year 2, it is R2 minus, it's R2 minus C2 over 1 plus A to the power 2. Okay. And also for the third year, I should take a separate term, which is plus R3 minus C3 minus C3 over now 1 plus A to the power 3. Okay. But now, from now on, yani for the remaining of my summation, no need to write all terms, because from now on the R becomes constant. Yani from the fourth year, R will not vary and C will not vary. So I will add plus summation from what to what? From year 4, from 4 to what? To 20, to the final year. I will do the summation of Ri minus Ci. Okay, so I is varying from 4 to I equal to 20. Okay, So from this year to this year, I should do the summation of Ri minus Ci over 1 plus a to the power n. 1 plus a to the power I, sorry, which is the corresponding number of years. Okay, so this is my term, this one. Okay, so I decomposed my term. Here I should decompose it as I told you, because the income is varying over years. If the income was constant over years, then you just calculate it as one term, because you have from a mathematical formula here. If we go back to this formula, in case C and R are constant, because you have Ci minus Ri minus Ci. In case this term is always constant, you take it outside of the summation, and that what will remain inside the summation? What will remain inside the summation is only 1 over 1 plus a to the power I. Okay, so in this case, this term can be computed from a mathematical equation. It will be equal to 1 plus a to the power n minus 1 over a times 1 plus a to the power n. Okay, so this is why we can say that when this term is constant, then I can just calculate it in one step. I take Ri minus Ci outside of the integration, outside of the summation, I mean, and I replace sum of I from 1 to n by this equation. Okay, now in our problem, since it's a little bit different, we have for the first 3 years different R, then we will decompose this term. We will decompose it like we did. Okay, so for the first 3 years we will take separate terms, and now for the summation we will do the summation from 1 to 20. Okay, now how to continue, how to calculate this term, we will see in detail after. Let me just continue the expression of NPV at year 20. So we should add here plus the salvage value, which is the salvage value is 400, but we shouldn't forget to divide by 1 plus a to the power 20, which is the lifetime of my system. Okay, now to be able to finish, first we will find the expression of what is R1, R2, R3, okay, to replace them, and we should find a formula to calculate this summation from 4 to 20 of this term. Okay, so to start with, what is R1? They said that the selling price for the first year was 0.13, okay, euro per kilowatt hour. So R1 is 0.13, which is in euros per kilowatt hour. We should multiply it by the number of kilowatt hour per year of our turbine, okay, which is what? Which is 7,500 kilowatt hour per year. So we get that R1 for year 1, okay, we have that R1 is 0.13 times 7,500. It will give you a value of 975 kilowatt hour. Okay, if you want, I will remove per year, because by definition R is the income per year. Okay, this is the definition of R. So this is
euro.
Yes, sorry, euros. Yes, of course. Okay, now for year 2, R2 will be different. Instead of 0.13, I will just replace 0.13 by 0.12. Okay, so in calculation of R2, I have that it is equal to 0.12 times 7,500. It will give me 900. Okay, it's 900 euros. So this is for R1 and R2. Now For R3, I will repeat, I will do the same procedure. And I have for third year, it is 0.11 euros per kilowatt hour. So R3 is equal to 0.1 times 7,500. It will give me 625. Okay, it will give me 625 euros.
825.
Yeah.
It's 825, not 6.
825, I mean 825, of course. Because look, each year it's reduced 750. Okay, so it is 825. Okay. So now for the last year, which is from now on, yani, from now for year from year 4 to year 20, from year 4 to year 20, it becomes constant. Okay, R becomes equal to Ri is simply 0.1 times 7,500, which will give us 750. Okay, so from now on it is equal to 750 euros. Okay, very good. So now I am done with R. Concerning the cost is constant. Okay, so for the cost, C1 is equal to C2 is equal to C3 equals to C4 equals to the cost we calculated together per year, which was what? If we go back, C per year was 120. Okay, equals to 120 equals CI. It is 120 euros. Okay, so now I still only need to find what is this term, summation from 1 to 20 of Ri minus Ci over 1 plus 8 to the power n. Okay, so this is the only term I still need to compute. Now, since so here it's summation from 1, okay, from 1 to 20. Okay, so because after year 4 this term becomes constant, I can take it outside of the summation. So I can write that this is equal to Ri minus Ci. I will take it outside, and I should compute what is the summation. What is the summation from here? The summation is not from 1; it will be from 4. Okay, because in my problem here for the first 3 years, so here pay attention here. Since you already accounted for the first 3 years, we will not put summation from 1. We put summation from year 4 to year 20. Okay, and we want to predict what is this summation. So summation from I equal 4 to I equal to 20 of 1 over 1 plus a to the power n. So here you need to do a small, if you want, a small technique that will help you to do your calculation. Because this formula...
You can do sum of everything minus sum from 1 to 4. No?
Exactly. This formula is valid when we start from 1. Okay? So we should pay attention that this formula here is valid when we start for I from 1 to n. Now, how we can play over around it? So we can say that summation from 4 to n is simply the summation from 1 to n minus the 3 first term. Okay? So we can replace this by saying that it is equal to Ri minus Ci. I will take it outside. I will keep it outside of my summation. Times now my summation. Okay, I will write it in a different way. I will do summation from 1 to 20, and I subtract from it the first 3 terms. Yani for I equal 1, for I equal 2, and for I equals 3. So I will write it like this. So it is now the summation from 1 to 20, but I will subtract from it minus the first term, which is 1 over, for year 1, it's 1 over 1 plus a. For year 2, it's minus 1 over 1 plus a squared. Okay, and for the third year, it's minus, and for the third term, it's minus 1 plus a. And I just played with the formula. Why I did this? To appear summation from 1 to 20. Okay, and if you do a summation from yes.
This calculation can be done on the calculator without doing all of it. Like you can do the summation of.
If you have an advanced, you mean you have an advanced calculator and you can directly put summation from 4 to 20?
Yes, you can put it in
the
input.
because some of you don't have the, if you don't have the advanced calculator, I'm just giving you a technique how to find it. Okay? If you have, it will be better. If you have the advanced calculator, it's fine. So you can use it.
Miss, even it doesn't have to be advanced. The normal scientific one can do it. If you want, maybe you can teach us how to, we can show the class how to do it with the normal one.
It's fine. Okay, it's fine. Okay.
Yes, also if we use Excel, بس مثلا أنا I have a question. If we use Excel, we skip everything here لأن إحنا بس بنفرجيك الcash flow and then we do the IRR. But what do you need us to explain in the writing part in our Scratch? لأنه حرام نكتب كل هول إنه technically speaking if we use Excel كثير بنوفر وقت.
Even if you use Excel, it's fine. If you use Excel, what will be reduced هو calculation of summation بس. يعني بس إنه أنت you should divide.
نحن بنعمل drag from year 4 to year 20.
Okay, it's fine. So you can say that this term I calculated from the, I use the calculator to find this term. It's fine for me. But for the other one, you should show me that you divided into, you consider it for the first years that it's R1 minus C1 over 1 plus A. بس please انتبه هون، أنت هلا عم بتقلي calculator، بس أنا اللي بدي أقول لك إياه إنه هون it's all function of A. يعني A is not given. مش إنه أنت معك A and you are doing the summation. You are trying to يعني if your calculator also can give you a general formula function of A, it's fine. But if you don't have A, نعم.
في function على Excel بتطلع لك ال IRR ده.
Yes, directly. يعني نحن بس بنحط ال R1 minus C1 in the cell, and then we write the cash flow. نحن بنكتب إنه minus 6,000 بيكون at year 0, and then we start working لأنه أول شيء initial cost. بعدين بنقول R1 minus C1 it's at year 1, R2 minus C2 at year 2, R3 minus C3 at year 4 لأنه at year 3 قصدي. From year 4 to year 20, we have the same R4 minus C4.
I see.
Salvation بنزيد على year 20 وبنعمل IRR بس.
I see what you mean. But here, A is not given. يعني you will find it function of A, you mean?
لا نحن بس بنحط ال value of the profit, and Excel gives us directly the IRR. يعني هو بياخدها as function لأنه بيعمل في function NPV included in Excel. So نحن بنحط له IRR هو بيحط NPV equal to 0 بيحلها بيعطينا ال I. ال A.
هلا أنا in general أنا بالexams يعني مفروض أنتوا تعرفوا هالتكنيك بلا Excel، بس now I cannot control. يعني حتى لو قلت لكم ممنوع تستعملوا Excel, I know that you can use it. يعني فما فيني ما فيني فوت على your computer to know if you will use it or not. But the purpose of this part is to understand how we calculate these issues. مش إنه بس نحطهم على Excel ونطلع.
لا yes of course we understood. بس إنه نحن عم نقول إنه بس ليساعدنا Excel بالcalculation أحسن ما بركي إنه because you know model based وما فينا نرجع لورا إنه بيكون plus يعني for us إنه a tool that.
But anyway أنا عم قلكم إنه أنا I want to see details. يعني أنتم حرين تستعملوا Excel، حرين تستعملوا اللي بدكم إياه، بس إذا Excel عطتكم دغري ال ROI without justification, it will not work for me. يعني أنا حفرجيكم how I can find it in my way. Okay. هلا if you want to use Excel as a verification or to help you if you want to get a certain idea, I don't mind. But I want to see all details in your draft. And the details will show how you calculated each term separately. Okay?
Okay, Miss, نحن simply what we're going to do is put in the whole formula exactly how you did, but the part where you sum, I will just say using Excel the sum is وخلص.
It's fine, it's fine. Okay? بس هون بدي بس فيكم تنتبهوا انه هيدي السميشن is function of a variable. فانتوا وقتها بدكم تجيبوا ال ROI بدنا نعملها هون by iteration. هلا هو اكسل بيعمل iteration هو يعني it's a function فدغري بتطلع لكم الريزولت. بس انا I want to see the details يعني بدكم تاخذوا several values for A and you should find for each value of A what will be NPV at year 20 and based on this then يعني مثل ما حنعمل هلا حنشوف how we can track at which time we get NPV 0 for which rate.
You want the linear interpolation?
No, not the.
You want us
No. Not the. Let me finish. You will see how. Let me finish. Okay. Let me finish the problem. You will see how we can get it. So, just for this technique, all I did is that for the summation, okay, I split it into two parts in order to figure out this term. اللي أنا I know the formula for it. Okay, اللي هو sum I from 1 to 10. Okay, اللي هو فيني دغري استعمل for sum of I from 1 to 20. I can use directly this formula here. يعني I can say it's 1 plus a to the power 20 minus 1 over a times 1 plus a to the power 12. So if I go back to my calculation here, now I will replace back into my formula and you will see what we will get. Okay, so now by replacing back in the formula, okay, what I will get is now if I replace, I have that NPV at year 20 is equal to first minus 6,000. Okay, now I will replace R1 and C1 by their values, so it's plus 975 minus 120 over 1 plus A. I have plus 900. So for the second year, it's 900 minus 800 minus 120 over 1 plus a to the power 2. For the third year, I have 825 minus 120. So here, as you can see, always it's minus 120 because the maintenance cost is not changing with time, but the income is changing for the first 4 years. So plus 825 times 120 over 1 plus a to the power 3. Okay, and now I will replace my summation. Okay, for my summation, in factor outside I have what? Ri minus Ci, which correspond to R after year 4. After year 4, we have calculated that R is 750, and we will subtract from it 120. So we have, so it's plus 750 minus 120 times, now I will include the term, okay, I will include the term inside the bracket, so this one, which will give me sum from 4 to 20, okay, which is 1 over So it is the summation. Instead of summation from 1 to 20, I will directly replace by the formula, okay? Because this summation will give me which formula? It's 1 plus a to the power n, so I will directly replace here, okay? So I will convert sum from year 1 to year 20 into 1 plus a, 1 plus a to the power 20 over minus 1, okay, over a times, so over a times 1 plus a to the power 20. This is from the formula sheet, okay, we have seen together. So I computed the summation function of a, so to the power 20, okay, and now I will subtract the other terms in order to obtain at the end summation from 4 to 20. So it's minus 1 over 1 plus a. So this term, okay. Now I am nearly done, okay. What you can do to simplify more is that since you have here over 1 plus a and here over 1 plus a, you can add the terms together. So here you have, for example, 975 minus 120, okay, which will give you, let's say here it's 855. You should subtract from it this term, which is 750 minus 120, which is 630. So in total, if you want, the final expression will be as follows. If I just take into fact the common factors together, okay, I get that NPV at year 20 is equal to first minus 6,000. Now for the terms that are common for 1 over 1 plus a, I have plus as we said 855. So I have 855 and minus this term, because here you have minus 1 over 1 plus a, which will give you 630, okay? So minus 630. So now I will directly, if you want, replace by the corresponding value, okay? So you will get plus 225 over 1 plus a. You will have also, if you do the same for 1 plus a squared, you take the common factor, you get 1 plus 150 over 1 plus a squared, and the final term you get plus 75 over 1 plus a cube, okay, and finally the final term is the summation, okay, which is equal to plus 630 times this term, okay, which is equal to the formula of geometrical series, okay. It will give you the value function of it. So what we did until now, we got the NPV.
There's also the salvage value, miss.
Yes, of course, also the salvage value at the final year, which is plus, I will add it at the end, which is plus 400 over 1 plus a to the power 20. Okay, now what to do? How to continue? What I did, I got NPV function of a, but as you see, it's a very complex equation. So if I want to calculate the value corresponding to 0, I need to do it if I don't have an Excel sheet or if I don't rely on a calculator. And even here, I am telling you what Excel will do. What Excel will do is it will iterate. It will try several values of a until reaching a certain interval, a very short interval, where NPV goes from a positive to negative value. So we say that this is a dichotomy method. So I iterate until reaching a very small interval where I have NPV between a positive and a negative value. and of course very close to 0. So I can say that I can compute what is the value of A, which will give me NPV 0. So for example here, to tell you how we do this, we try several values of A, and to not have to do several iterations, we do reasonable, we start from reasonable values. So as you know, in general, we said that 10% correspond to a low confidence. So we can start by 10%, compute the net present value, and then we go down with A until reaching NPV of 0. So I will write for you the list of results we get and how we can do the analysis to know what is the ROI. So for example, let's say we start by A equal to 10%. All you have to do is to replace in the equation you got, okay? I know here it's complex. In the exam, I will not give you a very complex problem like this one, and maybe I will not give you, let's say, 4 years of variation. It will be a little bit simpler in order to facilitate for you the calculation, okay? So for A equal 10, let's say, if I calculate NPV, if I calculate NPV 20, I will get a negative value. Okay, this means what? This means that I am over, if you want, for this low confidence, I will not profit. Okay, so this discount rate will be, of course, higher than the ROI. So what I should do, I should go down. Okay, so this is how you can know if I should go up or down depending on the sign. Since the sign of NPV for year 20 is negative, it is minus 251.594 euros. Okay, this means that A is very low, is very high, and confidence is very low. So to be able to have a profit, I should have more confidence. So what I should do with A, I should decrease A. So we can start to try. So if we try A equal to 5, okay, for A equal to 5, for example, we can calculate the value of NPV, and it will be equal to a positive value. So now we can be sure that A is somewhere in between, okay? So it's 2266.32. So now I am sure that my ROI is here in between 5 and 10. So I just need to do some more iterations to get the ROI in an accurate way. So for example, as you can see here, since minus 251 is closer to 0 than 2266, then you can say that A is much closer to 10 than 5. So now you can try A equal to 9. Okay, so for A equal to 9, I have nearly it's equal to, I get NPV equals to 141.57. So now I am close. I am sure that I am between 9 and 10. Okay, so I am between, so ROI is between